Greetings and welcome to the pod. My name is Mark West, and do you reckon you can swim around wave-powered devices like you can run around wind farms? I didn't know, so I asked Dr. Mark Hemmer, a principal research scientist leading the Sea Level Waves and Coastal Extremes team within CSIRO's Ocean and Atmospheric Climate Science Centre. Mark has conducted research into offshore renewable energy for over 10 years, exploring the potential of Australia's renewable offshore energy resources. But before I asked him whether we could swim around these things, I asked him, what exactly is wave and tidal power?
Yeah, so there's a number of different offshore renewable energy technologies, which is how we kind of group them together. So there's the wave and tidal energy that you spoke about. There's offshore wind, there's offshore solar, there's ocean thermal energy, there's salinity gradient. So there's a whole number of different technologies there. Some are more mature than others. Obviously, offshore wind, when you look at particularly Europe, but also rapidly growing in China, they are, that's a almost commercial technology, or commercial in some respects, but a lot of the other technologies are very much emerging and trying to fight for their space in the future energy landscape, I guess.
Okay. And so what is wave power? How does it work? It's not just waves crashing on the beach. There's a bit more to it than that.
So there's a lot of different technologies out there for how you harvest wave energy. So if you look back at cars 100 years ago, cars had all sorts of weird and wonderful shapes, and wave power is somewhat in the same state now, that people harvest wave energy through point absorber type things, where, a classic example is a buoy, and the oscillatory motion as a buoy is used to pull on a piston type thing, and that is converted to mechanical energy and then electrical energy. Other technologies act like a blowhole, so they set up an air chamber over the top of the waves, and as the waves go up and down within that air chamber, they force air through a turbine that can provide electrical energy. There's other technologies that have been tried in terms of long surface kind of snakes that have hinge points that harvest the mechanical energy into electrical. So there's, like I say, there's a whole range of different technologies out there. There's hundreds of different patents. There's hundreds of companies around the world trying to, like I say, find their place in the energy landscape to push their technologies forward.
And so how big do your waves need to be? Are they comparable to the waves you see at Bondi, or do they need to be much, much higher to work to generate energy?
Yeah, no, not necessarily large. So there's a range of different thoughts out there in this respect. So I guess early thinking was that you need to harvest the large waves, and there, that's where all the energy is. That's going to be great, but with large waves also comes large loads on structures, which makes it a really challenging environment to work in. So now you are tending to see technology developers aiming for that medium range wave climate, so similar to what you see off the east coast of Australia. Particularly in Europe, you're starting to see different companies aiming at even smaller wave climates than that. But I guess the east coast of Australia is kind of the range of wave climate that is kind of the sweet spot, where it's consistent, good wave energy, but it doesn't have the enormous loads too often to deal with that. So it's kind of finding that sweet spot in terms of ratio, in terms of having high wave power, consistent wave power, but not having too large an extremes that you have to engineer systems for.
And how does that differ from tidal power?
Yeah, so tidal power is really quite different again. So tides, as you know, they rise and fall twice a day, typically. Every now and then you find spots where it only happens once a day. And there's
Perth only has one tide a day. I had no idea.
Yeah, that's right. Yeah, and there's several other spots around the world, but so there's two tidal technologies. So, a tidal technology that's been around for decades now, and there's a major tidal power station in France that operates as a barrage system. So there, the tide comes into, say, an estuary. They've built a barrage so that the estuary floods, and then they hold that back like a dam, and it drains out through turbines, and acts like a hydro dam effectively. So there's been projects like that proposed for the Kimberley probably for the last 30 years, but they've never got up, and I'd be surprised if they do. They have quite large environmental impacts associated with how they change the flooding of tidal estuaries. But the technology that's kind of been pushed in the last decade or so is tidal stream energy, and so they, as the tides go up and down twice a day, they force a tidal current, a tidal stream, particularly in kind of restricted passageways, and that current drives a turbine underwater. So those tidal turbines look something like a wind turbine, but obviously under the water.
So I would have thought the passage of the moon around the Earth was pretty predictable. So this would be pretty good baseload power, wouldn't it? I mean, there's a lot of ocean and predictable tides. What's stopping this being our fundamental power source?
Yeah, so you're right. So one of the big advantages for tidal energy is its predictability and knowing when your power will come in. In terms of the comment about baseload, like I say, the tide goes up and down twice a day. And so when your tide is at a peak or at a trough, there's no tidal current. And so there are, while it's predictable, there are these periods where there's no power being returned. So there's ways to deal with that, and being so predictable, you know how much storage you need to fill those gaps and such like. So that's a strong advantage for tidal. What's holding it back, I guess, is what holds back all these offshore technologies, and that's operating in the marine environments. It's much more difficult than operating on land. So the cost of electricity that's delivered is ultimately higher than what we're seeing from the land-based renewable technologies.
That's interesting. So it's expensive, but we do lots of offshore drilling, and that's for energy. That's that presumably cost. Is that just cheaper because we're good at it and it's a mature technology?
Yeah, I think that's part of it. It's cheap. There's large amounts of it. It's an energy dense medium that's pumped out of the ground. Effectively it's quite a simple process in terms of relatively speaking, drilling a hole and sucking the oil out and delivering it. It's probably a little bit too simplistic, but yeah.
Yeah. And what are some of the other downsides? Are the turbines killing fish and dolphins, or is it relatively safe?
Yeah, so there's been lots of work over the last 10 years. So one of my roles is as an Australian delegate into an international group that looks at the environmental effects of these offshore technologies. And so, obviously these less mature technologies like wave and tidal, there's few sites around the world where they're actually deployed where you can measure these things effectively. But, there hasn't really been any severe effects from these devices. There's been lots of work looking at how fish and marine mammals behave when they're around submerged tidal turbines. There's been lots of concern about tidal turbines slicing up fish and such like. So there's been a big campaign in the Bay of Fundy in Canada where there has been tidal energy deployments. The local fisheries, both commercial and recreational fisheries, have been quite against tidal energy in terms of destroying their fishing industry. But really, I guess where we're at the moment in terms of the little bit of information that we do have, the evidence kind of points otherwise. So obviously, as these things are developed, I guess it's doing it in bits and just kind of gradually increasing deployment as opposed to putting a lot in and having severe impacts from staff and so forth.
Okay. And I was reading something that you wrote saying that I think it was wave power. There's enough wave power around Australia to basically power Australia a few times over. Is that right? Do you see this really escalating in the future?
Certainly, we talk about being resource limited or not. So there's enough wave power to meet Australia's needs, certainly. But I guess it's all relative. If you compare the size of the wave power resource to our solar resource, it's minimal, it's trivial.
Right, okay.
And so, that's a worthwhile comparison to make. But, there's advantages to wave energy. I spoke about some of the advantages of tidal energy, wave energy similarly. While it's also variable, it's not as variable as wind or solar, but it typically varies out of phase. So, for example, when you've got lulls in wind or solar, and you're quite likely to not have a lull in wave, and so they can even things out if they're deployed together.
There's some cool running races around wind farms in near Canberra. I was wondering if there could be some decent swimming races around tidal farms or wave power farms, but I'm guessing the turbines probably might make that not so safe.
Yeah, I think it's that's one thing that the community's looked at a lot is in terms of it's obviously at the moment any technologies have an exclusion area around them, and I guess that's as we see our marine domains being increasingly used by different sectors, there's this competition for space and how you effectively plan for that. Recreation's got a leg in there, fisheries has a leg in there, navigation, all sorts of things have a role to play in dealing with what is public domain essentially, and how those different sectors get a role in the use of that space is an interesting
aspect
challenge to work through.
Yeah. And another arm of your work is, I mean, you're the expert on waves. I think I heard you on ABC Kids podcast. You're Miss or Dr. Waves. So one of another aspect of your work is looking at the effect of climate change on waves and coastal areas and the erosion and whatnot. What effect will climate change have on waves around Australia?
Yeah, so that's my other hat is really looking at coastal hazards and in the context of climate variability and change. So I guess where I come at that is there's been a lot of public discussion around sea level rise and such like, and the effects that'll have, and a lot of those discussions are talking about sea level rise under the assumption that the wave climate's going to stay the same. But we can't talk about changing rainfall patterns and such like, and the changing intensity or frequency or paths of storms without recognising that's also going to have an effect on where our waves are generated and the directions and magnitude that they travel.
Okay.
So there's various things over the historical 30 years or so, or perhaps longer. We've seen quite a strengthening in the Southern Ocean waves. Part of that's attributable to ozone effects, but also carbon signal in that also. And so those Southern Ocean waves are seen in the observational satellite record.
Ozone effects? That's interesting.
So the depletion of the ozone hole has led to pattern of storms strengthening and intensifying further south. Has been an ongoing trend over the last 30 years. So the recovery of the ozones tended to reduce that signal, but we expect it. It's still likely it's a balance between how much the ozone hole recovers versus how strong the carbon signal becomes.
Right. Okay.
And so the Southern Ocean is a very large signal that we've seen historically, and we expect to see in the future. And then there's other effects as well in terms of strengthening trade winds, effects on the waves through the tropics, and these have effects on the direction that waves propagate in terms of the annual mean type wave direction. That has net effects on shoreline position and a whole range of things, and depends on, it's a lot more regionally variable than the effects you see from sea level rise, for example. So it's much more challenging to bring that down to local scales.
That's interesting. So, because I think immediately when you think of climate change, you might think of the sea level rise, but I hadn't really thought through the idea that the winds will change, which will then change that ocean wind interaction, which has effects on waves, and the waves then batter the shoreline.
Yeah, that's basically it. Yep.
And what do you think the implications are for? I guess it's very difficult, as you say, it's difficult to model at that sort of small level. But what do you think the implications could be around Australia?
Yeah, so I mean, a nice example to point to is the 2016 storm in Collaroy. So that wasn't necessarily a very large storm when you look at just its magnitude. I think in terms of wave height, it came in as about a 1 in 20 year event. But what was particular about that storm was the direction it came from, being unusual for the general orientation of that coastline. So that orientation of that coastline essentially evolves to some equilibrium with the wave climate. And so if that wave climate changes, then that equilibrium, if you like, of the shoreline position will respond to that changing wave climate. So you can see it might be retreat of the shoreline, but quite equally it might be recovery of the shoreline or advance of the shoreline in different places. So, like I say, it comes down to very localised scale effects in terms of how that will play out.
That's interesting. So I hadn't thought of that either. So the direction of the wind, basically, that it's going to change.
Yeah, that's right.
Change the coast, literally change the shape of a coastline.
Yeah, yep.
That's kind of got a lot of issues for city planning, doesn't it?
Yeah, obviously that's on soft coasts, so on sandy coast, that's where that'll happen. Obviously on a rocky coast or an engineered coast, that's not a process you need to worry about. Yeah.
Yeah, right, okay. And I imagine in some of the lower lying areas around, I guess the north of Australia is a bit lower, isn't it? I'm not sure, but
Yeah.
That's going to have a lot of issues, a lot of implications changing the coastline.
Yeah, potentially. I mean, that's one process that plays out. There's many other coastal processes that also play out. So how you bring these processes all together and look at the effects together is the real challenge, I think. Yeah.
And so just finally, where's your research heading now? What are the new developments that you think coming up?
Yeah, so I mean, one thing that's quite exciting in the context of offshore renewable energy is recently there's been an announcement of a Blue Economy Cooperative Research Centre, and so this is interesting. I mean, the narrative behind that Blue Economy Cooperative Research Centre is really about aquaculture industry and allowing that to move offshore so it can expand and become a larger industry than what it's capable of in its nearshore waterways. So when an industry like that needs to move offshore and effectively sever its ties to land, which is where it gets its power and fresh water and such like from, then it introduces a number of challenges. So how will they get their power when they're operating offshore? And so that kind of introduces power demands offshore, and so that's a potential market for some of these offshore technologies. So that's it's a significant program that's going to go on for the next 10 years. It's got some really interesting aspects to that. Like I say, it's lots of good science around the aquaculture aspects, around the offshore engineering component of building these platforms that can deal with offshore environmental loads. There's the energy component to that, and then there's the environmental and social considerations associated with doing that as well. So some really interesting things I suspect will come from that program. So that's what I'm excited about at the moment.
Okay, that's a fascinating idea. So it's aquaculture, so I guess fishing is a big part of that, but what else do they do? What else do we need to take offshore?
Yeah, well, that's so. I mean, my predominant interest in that is from the energy perspective, and so the way I've been pushing it is there's a lot of industries that have an energy demand offshore that don't necessarily want to be connected to shore, and so at the moment, those energy demands are predominantly met by diesel, which is probably the worst fuel we can be using for a range of reasons, for expense and emissions. And so what I'm interested in is, how can we meet the demands of those offshore technologies more sustainably with low emission technologies? And so that may be roles for wave or tidal and offshore wind technologies, but there's also interesting roles there for different storage technologies, whether that be battery or whether it has place for hydrogen.
Right.
When we talk about, this is one of the nice things about aquaculture, in that you start talking about the co-benefits of different technologies. So aquaculture has a strong demand for fresh water for various reasons, and also oxygen. So they're producing their oxygen through electrolysis. So hydrogen, in some respects, is a byproduct of their activity anyway. And so if you're producing hydrogen, then you can use that as storage to even out your energy loads from some of these variable energy technologies.
That's pretty cool.
So there's nice energy, and then depending on your scale, then potentially you've got a hydrogen supply that you can use to fuel ships that might service a thing, and it depends on how big you want to go, really.
Yeah, I don't know how these things scale, but like I can imagine naively that sort of a local tidal plant with some form of storage would. I mean, that seems to make a lot of sense. So making them small, I don't know if that's expensive. I don't know what economies of scale there are when you scale these things up, but that does make a lot of sense.
Yeah, so I mean, tidal, you talk about scale in terms of tidal energy, so it's really interesting. So in terms of many different technology developers aiming at different components of the market. So some developers are aiming at, just trying to go as big as you can, so following the path of wind turbines effectively. But there is constraint there in terms of generally the water depth that these things operate in is constrained, and so they can only go so big. Other technology developers aiming at small scale and what they call kind of parasitic deployments, where they'll deploy smaller turbines on things like bridges and such like, where you get these much lower flows, but is a predictable and reliable energy source that you can harvest as well. So there's this complete different range of scales that people are aiming at.
Well, that's it for this edition of the pod. Thank you very much to Dr. Mark Hemmer from CSIRO for taking the time to chat about offshore renewable energy. If you'd like any more information on anything you've heard today, get over to the website at www.thepodpodcast.net. That's www.thepodpodcast.net. My name is Mark West. I will catch you next time on the pod.